Okay, so on cable, so since the conductors are embedded in this outer jacket, just by visually inspecting it, it's impossible to tell what's on the inside. So what they've done is they stamp, I don't know, about every 18 inches stamped on a piece of cable are specifications for that cable, or what its size is and how many conductors there are, right? So that information is stamped on that jacket at regular intervals. And what I want to do is let's go ahead and discuss some of the common things that are stamped on the outside and what they mean. The first and probably one of the more important things is going to be the AWG. And AWG stands for American Wire Gauge. And that is the size that's how much copper is inside of that cable, right, or that conductor, right? So the AWG is the amount of copper, and that is what determines how many amps can flow through, safely be handled by that cable, whether it can handle 20 amps or 60 amps or 15 amps. Remember, the number of electrons is what amps are, and so by having a larger surface area of copper, you can have more electrons energized and therefore carry greater ampacity. Now, the larger the AWG, the less copper there is, the smaller the conductor, right? So if I have a 16 gauge cable, right, that's smaller than a 10 gauge cable. They're inverted, right? Now, other information, and you can see right here that I have 14 AWG stamped on this cable. If I look over here, I can clearly see 6 AWG on this cable, right? So this is a larger conductor than this because this number is smaller. And here's a really big cable, and it's filled, it's a single conductor, and you can see how fine all of that copper is so that it can remain really flexible. Now, the other information that's stamped on the jacket is 3/C. That 3 stands for the number of conductors, how many individual pieces of wire are inside of this cable, how many conductors there are. And 3C says that there are 3 conductors in here, and they are color-coded, black, white, and green for ground. That is sometimes referred to as 12-3, where the first number is AWG, and the second number is the number of conductors. So a 12-3 cable is 12 AWG with 3 conductors. And a 6-4 cable is a 6 AWG, again American wire gauge, with 4 conductors. Let's look a little bit at power handling capacity, right? Again, amperage is related to the number of electrons. So the bigger the diameter of the wire, the more copper we have, right? The more copper we have, the more electrons that we can move along that wire. So the bigger the wire, the higher the amperage capacity. However, it is inverted for American wire gauge. Don't ask me why. 14 gauge is residential. A good extension cord will be 14 gauge and is good for about 15 amps. Sometimes you might even find, well, you will definitely find 16 gauge extension cords, and those are good for about 8 amps of steady, maybe 10 amps hard, steady use, right? But 14 gauge is general lighting and receptacles, and you'll find that in your wire, in your home wiring your outlets, right? 12 gauge is what we use in the theater, and that's rated for 20 amps. Right? So 20 amps is most commonly what we use in the theater. So that stage pin cable is 12-3, number 12 AWG with 3 conductors, and that's rated at 20 amps. As we move up, 6 gauge is rated at 55 amps, 3 gauge at 100 amps, and you can see the different sizes as we move up. As we move past 2 gauge and 1 gauge, we start to get into something that's called an aught, right? So 1/0, 2/0, 3/0, 4/0. And 4/0 is about the biggest cable that there is. It's about as big as we go, and that goes to up to 600 amps, right? And so that's just American wire gauge and shows that. Let's go to our next one, right? So there's more information on this cable, and I'll come back to this in the next video.